Hello everyone, have a good day for today. Alright, so let's proceed. I'm going to show you one example using Poisson's equation. So if you can to turn to your Cylindrical book, page 275 as shown here. 2005 example or problem 6.9. So let's summarize the questions. So we are given a case of cylindrical structure as shown here, cylindrical structure, and also the boundary condition given as when R equal to the 2 meter, then there's 0 potential, and also when R is equal to 5 meter, the potential becomes 60 volt. So that's the boundary conditions. And also we are given another conditions which is our original conditions, which is the rho v now no longer 0. The rho v now has a value which is 10 pico over R, right? This is volume charge density, so we have this unit coulomb per meter squared. So for this case, the rho v is non-zero, and we can consider as the not free charge medium. All right. So and also we are given the relative permittivity value, which is 3.6. So this is the structure of the case. Okay, we are given a case of cylindrical structure, and with the inner radius of A, we define ourselves, and also the outer radius of B, and the inner surface is grounded, and then the outer surface is connected to the supply of 60 volt. Alright, so since we know that this case is a free charge medium, it means that we have to use the Poisson's equations. So let's do it together now. So based on the Poisson equation, we have this equation: del squared V is equal to negative rho v over epsilons. And we know that the rho v value now is given as here 10 pico over R. So plug in or substitute this formula of rho v into these Poisson equations. Okay, let's do it together. Now this is equal to a negative rho pico over epsilon R. Okay, that's our equations for the Poissons. So since this is a case of cylindrical, as we know here, so we have to refer to the table of Laplacian for the case of cylindrical. So let's turn to page 92. You can find the table from page 92 to refer the formula for the case of cylindrical. So as shown in the book or in other references, you can see the Laplacian of V is given as 1 over R d over dr brackets R dv over dr close brackets, and then plus 1 over R squared d squared v over d phi squared, and then lastly plus d squared v over d z squared. Okay, so that's given from the table. Alright, as we can see from the questions, the potential only varies according to the radius, right? So in other words, we can simply ignore these two terms, whereby the phi and z has no effect at all on the potential value. So we just simply delete these terms, and the whole term here is equal to these equations as derived previously, a negative 10 pico over epsilon r. So let's equal them. So this whole term is equal to this term. So before we can simply delete, right, this r, the r from the left hand side and the r for the right hand side. So finally, so we have these equations, d over dr, the r dv over dr is equal to negative 10 pico over epsilon. Alright, so that's the equation so far. So again, to find the equations of the v, we need to integrate for both sides. Let's say the first here first integrations, and also here for the right hand side integrations. So this one you're gonna have here the r dv over dr is equal to negative 10 pico epsilon r plus a, right, plus a constant there. So that's after first integrations. So let's proceed to the second one. So before that, we have to move this r term to down here. So what we have here, dv over dr is equal to negative 10 pico over epsilon plus a over r. So that's after we move this r from the left hand side to the down hand side to the right hand side, but for the below part over there. So let's proceed the next part of it. So now we have this equation, a dv over dr is equal to negative 10 pico over epsilon, okay, plus a over r. Okay, now let's do together the second integrations. This one, the whole term here, right? So integrations and integration for both sides. So here you're gonna have the term of v given as 10 pico r over epsilon, and this one we're gonna have a ln r plus new constant as b. Okay, that's our general equation of v. So by using the boundary condition given previously, so you can substitute all the value of v and r to get the value of a and b. So the first case given as when the r equal to a, so the v becomes 0. So just put here the equation 0 equal to 10 pico a over epsilon plus a ln small a plus b. Then you can have the b equation finally. The b will become 10 pico a over epsilon minus a ln a. So that's our first equation using the first boundary conditions. So let's proceed to substitute the second boundary conditions, whereby when at r equal to b, the potential is 60 volt. So plug in the value. So here is 60 volts equal to negative 10 pico b over epsilon plus a ln b plus capital B. So again, let's rearrange the equation to find the v, the b only. So the b, gonna have here 60 plus 10 pico small b epsilon minus a ln b. So that's our second equation of the b. So let's equal them, whereby 1 is equal to 2 equations to get the value of a. So we know that from here the 10 pico a over epsilon minus a ln a is equal to 60 plus 10 pico b over epsilon minus a ln b. Alright, so let's rearrange the equation, combine the a term here with this a term over there. So you're gonna have the new term. Let's say I want to bring all this term to left hand side or to the right hand side. So you're going to have the a ln b over a. This one I bring over here, so now become positive, so b over a, and here is 60 plus 10 pico b over epsilon minus 10 pico a over epsilon. Okay, let's factorize the equation. So this one, you are going to have this term 60 plus 10 pico over epsilon equal to b minus a. Right, so finally you can have this a term. The a is equal to 60 plus 10 pico over epsilon times b minus a, the whole term here, and divide by this ln b over a value. So down here you are going to have ln b over a. Okay, that's our a equation. Alright guys, so let's proceed our steps to find the b term. So to find the b term, just substitute the a term into the equation 1 or 2, either one. So let's say I choose to use equation number 1 just now. So the b can be obtained from this equation. The b is equal to 10 pico a over epsilon minus a ln a. So put the value of a inside here, you're going to have the b term become this form, 10 pa over epsilon minus the whole term of a given as 60 plus 10 pico b minus a over epsilon over the whole term ln b over a, and then this one times with ln a. So that's gonna be our b term. So substitute all the b and a terms inside the general equations of v. So the v is equal to negative 10 pico r over epsilon plus a given as 60 plus 10 pico b minus a over epsilon, then the whole term over by ln b minus a, and then with times with the ln r, and then plus b as previously obtained here. So just put all the v value 10 pico ma over epsilon minus 60 plus 10 pico B minus A over epsilon over whole term B over A, and then this is your B, right? Line A. So that's our final equations for the potential for the V. So guys, make sure you have to substitute this epsilon to epsilon R, epsilon naught, whereby this epsilon R is equal to 3.6 given by the equations. Okay guys, so all the best. Let's try yourself and make sure you get the same answer. Alright, and thank you. Take care.